Ciao, I'm Andrew. Today I would like to teach you how to use the remainder theorem to find the remainder of this following polynomial division. So let's keep in mind what the remainder theorem is. The remainder theorem says that if you have some function f of x, which this thing is, you can call it your dividend, and you divide it by some linear function, call it x minus k or a, it doesn't make a difference, then the remainder of this division should be equal to, the function's value evaluated at the value of k. That was a lot of values there, so if that's a little confusing, just take a look at what we're going to do. What you need to do is you need to first identify your k value. Now notice that the linear function here that has the k is in the denominator. So this is basically the numerator, and it's being divided by this thing called the divisor, which is in the denominator. So what you need to do is you need to try and match, basically, this model to this given linear function and find the value of k. So what I can do is I kind of line up the x minus k along with this linear function. And I realize that my x is nice. I realize that this term, the minus sign is perfect. And it has to be a minus, by the way. Do not turn that into a plus. And therefore, the k value is going to be a 4. It's a positive 4. All right? So this one was pretty simple. K is going to be equal to 4. I don't really like that method, though. In this case, it's nice and easy, but I think a much easier way you can automatically do it very simply is take your divisor, set that bad boy equal to 0, solve it for x, and whatever you get as a result, that value here will represent k. So if you notice, it's the same value as we found before. This is k. The nice part about this method is that in case you have a coefficient here, you can actually still use this method to find k. It's very nice. Okay, so if you had something like 2x minus 4, you can still use this theorem. You just have to kind of set it equal to 0, find your k that way. Now, I'm out of breath. That's probably not good. But let's keep going. So now that I have the value of k, what this remainder theorem says is that the remainder of this division is going to be equal to the function's value evaluated at k. So all that means, it's a technically complex way of saying, just take your k value here, or whichever one, right? It doesn't matter, they're both 4, and plug it in for x. Evaluate this thing, meaning simplify it and solve. And that's going to be the remainder. So you're going to take negative 3, multiply it then by 4 squared, plus 6 times 4, plus the 24. 4 squared is going to be 16, right? So it's negative 3, multiplied then by 16, plus then this should be 24, right? 6 times 4, and then plus the 24. Now 16 times 3, you can do that on the side. That should be 48, right? But 16 times 3 is going to be 8. 3 times 1 is going to be, what the heck is that? That's an 8. There you go. 3 times 1 plus 1 is going to be a 4. So 48, but don't forget this is a negative. That's positive, so it should be a negative 48. Okay? Positive 24, you can combine those terms. That should be, oh, wait a minute, a 48 and negative 48. Oh, 0. The remainder is 0. So this thing should divide into this evenly and perfectly. Now, there's another way to do it. The remainder theorem is nice and simple. It's kind of easy peasy, but you can use synthetic division if you like, right? So what we're going to do is, I'm just going to show you very quickly. Let's do some synthetic division. And yeah, let me show you that the remainder is 0. Bam. So here's our synthetic division table. The number of columns here has to equal the highest power of x plus 1 of your numerator of the dividend or of your function f of x, right? So the coefficient here that goes into the first box is going to be the coefficient of x squared, then this goes in the coefficient of x, and then your constant term. So the coefficient of your x squared is a negative 3, coefficient of the x is going to be a positive 6, and coefficient of the constant term, well, not really coefficient, just constant, is 24. I'm going to run through this as you can kind of see, but if you need more practice, check out our channel because I think I have like 50 videos out there on synthetic division where I take the time to walk you through the process, all right? But at this point, if you're using the remainder theorem, hopefully you should have already done synthetic division. Anyway, then what we need to do is figure out the value that goes on the outside, and what you're going to do is take the divisor, x minus 4, set that equal to 0, and solve it for x. And oh, isn't that interesting? Because that's kind of what we did before. It's almost like your k value. So you're going to plug the 4 in there, okay? And now all you're going to do is follow the division algorithm, which is just a complicated way of saying series of steps. So we're going to take this bottom value, -3, multiply it by the 4. The result goes into the next adjacent cell, which is -12. Then you're going to add this on up, which is -6. Then you're going to take the -6, multiply it by that outside value, which should be a -24. Then you're going to add this on up, and wait a minute, the remainder is 0. Remember, the remainder of synthetic division is found in the last column. Okay, this is the remainder. This is then the coefficient of your constant term, and this is the coefficient of the x term. Remember, it changes, okay? This was x squared up here, this was x, and this was your constant. That's not what happens down here. Anyway, as you can see, more than one way to solve the problem, all right? So thanks so very much for tuning in. I really do appreciate it. If we helped you out at all, we'd love to help you with more stuff. We got chemistry and physics out there. We got thousands of videos, solve solutions for you to help you through your class, whether you're in high school or college. And if you wouldn't mind just telling some of your classmates about our channel. We're so thankful for all the support you've been showing us, and we want to keep producing content for you. So we love what we do. See you soon.